Okay, Lawrence, if everyone is in, I will start the presentation now. You can start to tape it because it's registered too.
Okay.
So thank you very much for joining us at this webinar. As I mentioned, it's an honor to be invited by natureplus and Wiebe to talk a bit about what BC does and how we see the future of building, and also how we can do that in a short loop with a minimal negative impact and with a maximum positive impact on the rest of the world, on society, on nature. BC is actually short for Brussels Corporation, but that's a bit the only thing that is simple about us, because we are also a three-folded entity with BC Architects, BC Studies, and BC Materials. BC Architects is a bioecological architectural bureau. BC Studies is a non-profit workshop aimed and focalized entity that is a non-profit. BC Materials is the material producers. And I'm just sketching this because for us, there's a very natural flow between these three entities that is quite dialectic, and it is quite fruitful and insightful and inspiring for all the entities and the people who are in it. And it's also a bit to break down the walls that exist between the different aspects of architecture, of materials, of design. And in this way, we really contribute to each other activities and to the flow that is possible. Maybe as the opening statement, we should mention that for a very, very long time, up until deep in the industrial era, it has always been a matter of common sense to design for the long term in scarcity, and also in short loops, we should mention, because up until the industrial era, people used to work with close by materials that were available, that were handy, that were easy to maintain and easy to process. And so in that sense, circularity is not a miracle, but actually a quite straightforward strategy that we should revalorize and reappreciate. Here you have a classic example of what has been done in lots of Italian, but also in other countries' churches, where elements of the Roman building style have been reappropriated by the Christian churches. But we also have this example a bit closer by. The typical way of building a farm in Flanders was to use lots of straw, oak beams, also reed as a roof, lots of clay, plasters, cob, and in certain ways also other earth-based materials. It's a very clean and nice way of building, the vernacular way of building, because it was also possible to dismantle all these elements and reuse them again at another site without actually having to do a lot of processing or a lot of energy use. And we saw this in Bokrijk, where the beams of the oak were actually numbered, so that people who would dismantle them later could really reuse them on the spots, reinstall them, and make a different structure or make a similar structure. And for the renovation of this building, which was one of the first projects of BC Architects, we installed a rammed bar that you can see on the right side down. But in this way, you see that although the farming is obviously not the same anymore, this kind of building approach has a lot of merits and should be followed upon also in larger structures. As you know, architects try to design for the long term, but there are lots of costs that are underestimated or underappreciated. And for example, the structure is something that is considered as very, very costly, but actually a lot of internal services and other expenditures in a building are also quite costly. So it also means that architecture is not that important as a lot of people think. It's also a matter of material use. It's also a matter of pre-design and availability of materials, because we know that we are running out of materials quite fast. I think in 2020, researchers found out that the amount of waste that we created on this planet is actually surpassed the amount of biomass. So all the trees, all the plants, all the creatures in the world was actually surpassed by the amount of waste in the world. And one of the top quantities of waste is concrete, obviously, but also baked bricks and asphalt. So we know that even if we work with a circular economy, it still has limits. And if we would all build very, very big houses on a circular base, we would still be ruining the planet. And it means that even if we think from a circular perspective, we also should keep in notice the kind of sufficiency needs, and aside from sufficiency, also the complete reuse of the materials, because recyclability is not the only thing that matters. This is a bit why we try to prototype a lot in our practice. We see that prototyping can help titillate the minds, can help stimulate the imagination. And our imagination was really triggered in a very, very revealing and a very enlightening way almost 10 years ago when we did this first project in Burundi. And it's actually in a very small town called Muyinga. And there we discovered that it is perfectly possible to build with excavated earth. As architects that would just finish the architecture school, we came there and we thought it's going to be impossible to build here because there are no classic building material shops. There are no availabilities to produce them ourselves because there's lots of hindrances and obstacles. And it's actually a contractor who explained to us that it's perfectly possible to build with excavated earth and with lots of other local materials, bio-based, for example, that could be valorized on the spot. For us, it was a big revelation because we used to think that it, as architecture trained to work with steel, with concrete, with baked bricks. But as we saw on the spots and as we learned on the spot, it's perfectly possible to use these kind of excavated earth. As you may know, in Africa, there's lots of laterite. It's a very reddish earth that has very good characteristics for earth building. It's quite strong. It doesn't have to be mixed that much with other earth streams. But it's actually there that we learned how to really work and valorize with local earth. And we actually saw that it's a very circular solution. But for people who build there, it's also the most standard and the most accessible solution. For them, it is the solution and it's an efficiency aspect. Here we still, in Belgium, we still have to learn a lot in that sense of using what is available in a short loop instead of seeing a bit the whole world as a supermarket where we can buy materials from all over the world. And this is also what we did in Arles as a team, BC Architects, BC Materials, the London Bureau Assemble and Atelier Luma. Arles is a not so big town in the south of France, where the foundation Atelier Luma has bought a number of buildings that are derelict, that are used to be old train stations. And our mission there was to really start seeing what is available around in a perimeter of about 100 kilometers to see what we can use, what we can source in a very short loop to make materials, to renovate a number of these train stations and see what could be done with the materials that are available in the land, in the quarries, in the earth streams that are available. Here you can see some pictures of a quarry at Sarrazin, also some excavated earth from different sites. And for example, rice husk, that is one of the most common plants being cultivated in Arles, and that can be used for insulation of straw, for example. Here you see a number of maquettes that we did, and in the back you can see some of the first earth plasters that we tried to make based on the loam and the clay and the sand of the specific site. Here you can see some designs and the future maquette that would be implemented in this last year. We had an opening in May 2023, and I would recommend a visit. It is a quite interesting site because it has both productive aspects and a kind of showroom aspect, and at the same time on the top floor, on the first floor, a lab. And for this site, which is completely bio-local and circularly made, we made a kind of, for example, rice straw insulation panels that are acoustically much better. They are situated at the ateliers. We saw that it was possible to kind of brand them and really compress them together, and they are situated at the left side. We also made typically ram dirt. You can see the picture on the right. A ram dirt that is based on typical elements of quarry waste, earth excavation, and gravel from the site. You can see here the different elements that you can bring together that are practically CO2 neutral because they don't have to be baked, they don't have to be burnt to be used. And when you blend these elements and ram them together, you can make very decent structures. We obviously had to test them and see how much strength that they could bear, how much load they could bear. And so we made a very, very specific ram dirt based on sources from this site to be able to implement it in the renovation of the train station. Here you see some of the larger ram dirt structures. We worked with some of the best contractors in the world who do ram dirt, and we were really in awe of the excellent execution of all that they did. Here's some of the tiles that were left over from the roof. There we made a cacio pesto, so like a finish for the outside, and a terrazzo floor with it. And last but not least, we also made a plaster made on algae. As you know, algae grow with CO2 as a kind of food for them. There's lots of algae in the Camargue, which is the natural park next to Arles, and we blended some of these algae with different plasters to obtain different colors, because most earth colors for plasters are usually gray, brown, or reddish. Now with these kind of algae, you can also go towards green and blue, and it's just an example of how far you can go using bio-based and earth-based materials in a perfectly CO2 neutral approach with making a healthy application. Here you can see some of the clay plasters that are mixed with poppies for an acoustic finish. And we also want to show you a bit the scheme, because this is a presentation about the short loop. It still involves lots of work and lots of people and lots of good contacts between both contractors, suppliers, executors, so like contractors and architects. So it is quite a puzzle to make, but it's quite an interesting puzzle to make, because we see that the short loop brings a lot of extra value to the building chain. And we can see that even people who we worked with, contractors that were asked to come to Arles to apply certain materials, have even stayed there as a growing market that they saw for plasters, for blocks. And so we can see that both the combination of using local materials and bringing in external help can be a very valuable one. We also saw that by using local materials and hiring local machines, you can really reduce the impact of the constant transport, which is reduced in a structural way, as Arles is almost 800 kilometers from Brussels. Aside from this production of materials, we also did a lot of workshops with students from different corners of the globe in both, for example, ram dirts, bio-based plasters, even straw husk. We really think that it's very important that people can learn how to apply these materials, as there is a big need. I don't think I have to explain that to people associated with the natureplus, that there's a very large need for people to learn how to make and produce and apply these kind of new materials that are as old as the street, but that are still new for a lot of architecture students and even architecture groups. And so this is why we really delved in quite deep to learn lots of people how to make earth mixes, how to make different bio-based installations, how it works, how the humidity regulation works, what are the assets. And then you get a finish that is similar to this. This was at the opening picture by Joseph Halligan. And for us, it's a bit some of the best looks that our ram dirt can give, and the best structure that ram dirt can give. There's an ongoing opening there, so if you're in the neighborhood in Arles, I would recommend a visit. And we think that that this is a very nice combination of bio-based reuse and clay plastering, clay-based, earth-based materials. So this is the final look. Now let's delve a bit deeper in what BC Materials does. BC Materials worked a lot on Arle as the producing or the co-producing entity that did both the research and development. But it started for us in 2019 when we observed as architects and as people committed to the circular transition that in Belgium alone there's about 37 million tons of excavated earth every year. This is a huge amount, but I don't have to explain it probably, that practically at every construction site there's some excavation happening, some excavation going on. This causes a lot of transport too. I think in Brussels it's about 100 tons, 100 trucks that are exiting Brussels every week to stock it at a temporary stockage field usually, where the transport usually takes it up again towards, in the case of Brussels, Flanders and Walloon, to be dumped in mines and quarries, but in a lot of cases also unfortunately in some cases also to the Netherlands and to France. We have in Belgium 37 million tons, I think also because, as you know, the Belgians have a brick in their stomach. They want to build everywhere. We probably have the worst spatial planning in the world, but that also means that there's constantly construction sites going on, and there's lots of excavated earth that just doesn't find its place out of the country. And so we see that a lot of contractors who are working with excavated earth have more and more problems of using this earth or valorizing this earth and are stuck with it. And some of the neighboring countries are even asking money to cross the border with this earth. And I'm not even mentioning the costs to dump it in mines or quarries. So this is becoming a bit of an issue, what to do with the excavated earth. And so our solution is quite straightforward. We actually intervene within the transport. So usually when the trucks are leaving towards the top, we can offer them to bring the earth to us, for example, like clay, silt, and sand, and we can produce on the spot. We have a production hall of about 1,300 square meters in Brussels next to Taxis, where we produce earth blocks, clay plaster, round dirt, and different earth-based materials in a standardized way, because the transporters and the excavators already know us now, and they know which kind of earth that we need, and we buy it at a very limited price, because for them it's waste, and for us it's an ingredient. Officially, juridically, you may notice, excavated earth is still considered as a waste. We have an exemption and an environmental permit from Brussels Environment to work with earth, because we follow all the standards and all the norms on polluted earth. Obviously, there is a lot of polluted earth in the world, not only in Belgium, especially if it's close, it's excavated close to an industrial site. But we also see that there's lots of excavations going on constantly, and we think that about half of the excavated earth that is circulating in Belgium, but this is the case for a lot of countries, can be really reused for making earth-based building materials. We also have a way where we can work on the spot. We've done this before, and that is a moment where the extraction happens, but that we're directly producing materials on the spot. It is a bit more complicated because sometimes we have to prototype and test the earth again to see if it has the right characteristics. And obviously, logistically, this is also more complex because a lot of construction sites usually don't have the place, especially in an urban context. It's very difficult to find the right place to find enough square meters to stock, to produce, to mix earth, and to be able to really produce significantly with regards to cost. The local production scheme where you start producing immediately after extraction will always be more expensive than a more standardized mainstream production. And so we see a bit earth as the game changer, the most obvious circular building material, because it can be reused, used on the spot. It's in a constant available stream that you can valorize it, and at the same time it can be disposed of again without hurting anyone or anything or even nature itself. And so our idea is that, yeah, as earth-based building materials are circular in both origin and destiny. In origin because they're based on waste, and in destiny because they can be constantly reused for an infinity times without losing any of their good characteristics. You don't have to bake them, so they're CO2 neutral, and they are not resource depleting, because there is an infinity stream that could be tapped into, and they are not being chemically altered, so they can be reused as much as possible. Aside from that, we just also have to mention, and we do this a lot because that they're CO2 neutral and that they're circular. For a lot of people, it's an externality that they will never feel. So we have to stress, and I think it's also one of the works of natureplus and Vibe, we have to stress the assets that it brings to people on the table directly. And so in that sense, we also stress the regulation of indoor humidity. We also see that earth-based materials are now more and more used in archives and conservation of art pieces, because it keeps the humidity at a very regular and constant basis. We also see with the changing climate, for example, a small country like Belgium that is quite north and that used to have a lot of colder summers has now had 2 heat waves in this summer alone. You all know that 2023 is probably bound to be the warmest year ever measured, and with the latest methodologies. So we have to start preparing houses for heat waves, and earth-based materials are heat mitigating because of their thermal mass. And aside from that, they also offer the good acoustic performance. So we really regularly pitch it also to offices and living rooms and spaces where some noise can happen. We also think that it really relinks people with their locality. I think in this globalized era, people have felt that a lot of stuff is flowing a bit out of their grasp, and we think local earth-based materials are a way of connecting people again with their community and what is happening around them. We have the specific luck, you can mention, in Brussels, that we have a typical Brazilian sand. That is the yellow layer that you see there. In Brussels, there used to be lots of quarries. Now, obviously, not anymore, but the new quarries are actually the big excavation sites, obviously, because there's lots of construction sites going on. And underneath the purple, you can see the Yperian clay that has very good qualities, and that is very present all over Flanders and even deep into Walloon. But you can also find it in the Netherlands, similar clay. And actually, in most of Western Europe, you have lots of earth building history that has been forgotten, unfortunately. But so here you see some of the typical excavation sites. This one is in Echo, and sand, the Brazilian sand that comes out of it. Here you see a bit deeper, a storm beacon. This is actually with some more clay. And obviously the gravel is also available because there's lots of demolitions going on. I think in Brussels we now see that there's regulation coming up that is stopping this demolition, which is a good thing. But the flow of gravel and of hard waste leftovers is not stopping, and I don't think it will stop very fast, actually. We decided to make first earth-based plasters on all of these, based on all of these materials. You can see the colors here, the brown, white, gray, and red. We also have now a finer plaster that we're launching in 2024. So we have both a base earth plaster and a finished earth plaster. We're also planning to make paint based on clay because we know that clay doesn't have any VOCs, no titanium, no toxic elements. And so we think it's actually a nice solution for people who want a quick do-over of their spaces. And we're also offering a number of other elements like these samples, the galtan finish that makes it a bit more weather resistant. And then you have the ram dirt, that is a very typical layered look, and the tools that go with it. And then a number of compressed earth blocks. And actually this amount of materials we've gathered under the name Lehm, which is a bit a reference to the German name, but also a bit to the typical Flemish name for the word. And we've started to produce some of these materials with industrial partners. You see here on the left Glass and Beton and Van der Moertelen. We saw this because we started doing this because we thought we, as a producing group, we started with about 50 tons that we produced and sold in 2019. Last year, we had 700 tons. But we also saw, even though this rise was quite big, that there was still a lot more potential. Because, for example, our compressed earth blocks were quite expensive. And we could make them at 1,000, 1,500 bucks per day with 2 persons that would constantly be busy with it. And at the same time, we knew if we would produce them like this constantly, we would always be double as expensive as a baked brick, which makes no sense, obviously, because energy costs a lot of money and our resources are quite cheap and we don't have to use a lot of energy. So we thought if we scale this, then we can do a better approach and we can produce more with less energy. And so that's why we decided to talk to Van der Moertelen and Glass and Beton to see what is possible with their infrastructure, leasing their infrastructure to make these blocks much cheaper and much more accessible. And it's a technique that we copied a bit from TerraBlock, the Swiss consultants who have done this before and who showed us that there's a real possibility of scaling lots of blocks like this. This is a bit the fruit of a research that we call YouTube, where we collected a number of blocks from different producers and could see what could be the possibilities if you scale up the production capacity of compressed earth blocks. Because a baked brick is one of the most CO2 intensive blocks that there is. We saw that there's lots of potential to change compressed earth blocks that are used inside as a substitute for the baked bricks that are in a lot of cases also used inside, because contractors usually just order, let me say, 20 pallets of baked bricks. Most of them are used for outside or the inner cavity leaf, but they're also used for the inside walls because they've been ordered together. But we could already reduce lots of CO2 just by masoning the inner walls with a number of these compressed earth blocks. This is a bit the research picture that we did because we wanted to show how much is possible with this approach. So on the right, you see the classic baked brick, but you can also make a leftover waste brick that you see on the left, and that could be a CO2 reducing capacity of up to 90%. So we tried this out, and here you see a shot of the production at Glass, where we can make 100,000 blocks a day by leasing and compensating for the infrastructure. And we see this is really a nice way to produce industrialized compressed earth blocks without losing any of the qualities and any of the ecological aspects of the product. Here you see a bit how we go into detail with Rodrigo from TerraBlock to see how we can make our formula, our block, work within an industrial infrastructure that normally works with concrete blocks. And so we tap into the industrial capacity that is present in Belgium, but that is actually present in the whole of Western Europe, to make products that are mostly decarbonized and that could be really valorized quite fast. And so what we could offer to people who are interested in earth-based materials is that where we used to have to say that our square meter for a 14 centimeter thick wall cost about 61 euros per square meter, which is quite expensive in comparison to the current market rate. We could go towards 43 euros per square meter, and so have a cut of about 35%, which is quite significant, as we also see that a lot of big brick producers had to turn up their prices especially during the midst of the Ukraine war, where the gas price went up and the margins of lots of big producers were just gone. They complained a lot about it because we see there that how fragile our economic system is when people who are dependent on a gas contract that is not flexible or that is fixed at the market rate, they actually lose their complete margin on baking bricks when the gas price goes through the roof. And as the gas producers are having a lot of leverage in this game, they could turn up the price whenever they wanted and sell to whomever they wanted. And some of these big producers had to temporarily close their production so they could give some oxygen to the team, because it was just not worth producing these quantities that they normally produced in a classic way. And so you can kind of see the shift coming up, where you can have a decarbonized industry where we lease the possibility of these materials, and where we lease the scaling up of these materials without having to go through all the fossil intensive problems that are already happening. With BC, we continue to innovate because we think that aside from clay plasters, clay paints, compressed air blocks, and rammed dirt, there are still some other possibilities. I don't know, I think it's in English it's called a screed. In Belgium it's called a shap. Even Flemish people call it a shap. It's like a subfloor that is usually poured with cement and that is very CO2 intensive. We have now made a screed based on excavated earth with a bioadditive that is as strong and as performant as a classic screed. It just dries a bit longer than a classic screed, but that can be planned within the building scheme. And I think it's a very interesting way of looking at something that is very classic, that is much used, overused actually, and that can be replaced by something that is 100% circular and practically pseudo-neutral. In Brussels alone, about 30,000 cube of screed is poured every year. We think in Belgium it's even much bigger because it's a very common way of working. And it actually doesn't have to be as strong as it has to be with cement, because it's usually insulated from water and all kind of infiltration. It can be used as a subfloor and finished off with a wooden floor or a tiled floor or whatever people can imagine, a cork floor, for example. But we also noticed that it offers the thermal mass that in some cases is needed. And I think, for example, it could also work very well for CLT structures. As we hear from some CLT builders, that one of the complaints that comes back regularly is the acoustics. We see that earth and wood structures are actually a very good combination because they kind of eliminate each other's weaknesses. As you know, wood building is a very solid, healthy, and CO2 capturing way of building. There's plenty of wood that could be used for structures and for building. Earth is not as strong as wood, but if you would do a complete building in wood, you would at some point have probably some troubles with acoustics and thermal mass. And so you need to pump some thermal mass. It's also one of the EPB standards, so it has to be done at some point. So you have to pump some earth into the building. Can be done with a floor, for example, with the shap, or with masonry of earth blocks, to create enough thermal mass so that the temperature fluctuation is limited, and at the same time create the acoustics. For example, with the earth blocks have about a 55 decibel reduction, so they're quite good in acoustics, but they're also quite heavy. At the same time, they could also be poured in this kind of earth screed. We call it a chapter, which is a reference to a chapter, and a chap based on terre, on what we call in French earth. And in this way, you can combine both something that is often needed in a structure and pour in the thermal mass that is needed for thermal mass. In this way, we can kind of see that wood structures are the locomotive of the bio-based building, and earth is a very handy complementary material that can be used for interior finishes, for walls, also for load-bearing walls, and for example, with screed that can finish it off and make the whole structure working better. This is a bit the way that it works now. The screed, it's actually mixed in a concrete mill. As you can see, it's quite a funny combination that something that usually makes concrete is now pouring earth. We've done a number of tests so far. It's gone through a long development phase. It started with just the idea: what if we make a screed based on excavated earth? And in this case, we started to test it first in a lab, then in a climatic chamber, and then on some test sites where we did it at a large size of square meters. And now in November, we've done the first 2 construction sites with this excavated earth and poured it, the chapter, on an existing foundation, and so far the results have been very good. We're talking about with the 2 partners of the scheme. There's both a contractor and a material consultant involved. The contractor is EMB, who has been pouring screeds for decades and who has quite a lot of experience. And for us, it's handy that we have a direct feedback from the site, because a contractor always is necessary to apply any kind of materials. This is sometimes a bit underestimated when you're launching a new product, that there's always somebody executing, and however nice a material or a theory sounds on paper, it always has to be applied, and this is a fresh material that has to be poured quite fast. It has to be done in an efficient way. Just to give you an example, I know from some concrete producers here in Brussels that they lose about 10% of their annual production just because the concrete mill truck is stuck in traffic and it doesn't reach the construction site in time. And so the concrete turns bad, and that alone gives them a 10% loss of all of their produced material. It's about 10,000 tons of concrete that they lose like this every year, and it has to be transported again to the other side. And so it's a typical wasteful way of working. We can tell with this material that it will also be stuck in traffic, obviously, but it has less a chance of turning bad, although it also needs to be applied quite fast. But it dries slower, and as I mentioned, this should be planned in the building scheme. But we also see that it has a nice carbon footprint, and we think with the upcoming construction product regulation that is happening, these kind of materials will be more pushed towards market and will be more taken up by the market, especially if the green taxonomy really kicks in and reuse of elements, of recycled elements, and both renewable materials will become a standard. As I mentioned, this is all what we call leem. We see it as a mix of both earth plasters and paint that are typically finished for walls, earth block masonry that are both load-bearing and non-load-bearing, and that can be used to build walls. And then rammed earth, that is a very specific material. You saw it in the Luma project where we use it as a structural wall. But this is quite rare because rammed earth is quite expensive in application. The other materials like plasters and blocks are quite straightforward, are not easy, are not difficult to produce, and are not difficult to apply. Where rammed earth is quite straightforward in the production, and based on the fact that it's based on waste, but that the application is quite intensive and has to be well coordinated, and is therefore quite expensive. But as I mentioned, we still think that there's lots of possibilities. For example, with the screed, but we also see possibilities of blending both bio-based materials with earth-based materials, and really leveraging this approach of a short loop, a circular design, and practically zero carbon impact. So that's it for me. You can find more on our site, www.lim.works. We also have a site, obviously, of BC Architect Studies and Materials. If you are interested in the more technical aspects of how you can use earth-based materials, we have manual guides, very, very elaborate guides on how to use earth blocks. It's about 120 pages, I think, where you can see all kinds of designs and schemes of how you can apply it in different situations and different designs, both inside and even outside in some cases. We've decided to publish them in Dutch, English, and French, because we want to spread this information as well as possible. I should also mention that BC Materials as a company is a cooperative and really is impact-based. So for us, aside from the fact that we want to produce as much materials as possible, because we think that our materials and the way that they are made and can be reused and remade is much better than the classic traditional materials that are mostly downcycled. We also think that it's important to spread this information, to train contractors to see how they can be part of the circular transition in building, and to spread the knowledge among architecture groups, among architecture students, among professors. We see lots of visitors here, about I think 1,200 people per year, because I think the way that we work can really be copied and copy pasted in lots of countries, near cities, close to cities, but also close to other parts of the country. So that's it for me, and now I'm all ears to all of your questions.